Does everybody know what is superposition? If not, let me know. Superposition. Principle of superposition. Does everybody know? So let me say true or false. नहीं poll से ही पता चलेगा, because many students don't actually speak in the class. There are only 4 or 5 students speaking usually. Do you understand superposition? Yes or no? In gravitation you've studied, we have done in electrostatics, we have done in many places so far, and I explain you in electrostatics also. Yes, so ठीक है, कोई नहीं, no worries. And really, Amashik, I like your confidence, like you're saying no straight away. If you don't understand, just tell me, right? So yeah, that's fine. So this is the result of the poll. 22% still do not understand. That is fine. So superposition क्या है? Let's actually understand from gravity's point of view first of all. So we said, oh, there is a mass 1 here and there is a mass 2 here. And this distance, let's take some numbers. Actually numbers में ज़्यादा समझ में आता है. 5 किलो इधर रख दिया, 10 किलो इधर रख दिया, distance दे दिया 2 मीटर. ठीक है, तो अब from this perspective, this 5 kilograms perspective, this has a force of g times 5 times 10 divided by 2 squared. Everybody understands this part? ठीक है, अब मैंने क्या किया, I put another mass here, let's say 6 kilograms at a distance of 3 meters. The law of superposition says just because I brought another mass here, that does not change anything to this force. This is as is. ये नहीं खत्म होगा, ये कम नहीं होगा, ये ज्यादा नहीं होगा, this will be as is. No changes to that. What will happen now is you actually find the new force because of this. This is g times 5 times 6 divided by 3 square. A new force here. And then what you do is you find the vector result of those two. So what principle of superposition says, when you find this, you ignore everything around you, just focus on these two, and then when you find this green one, ignore everything else, and then find the force, and ultimately add them together. Now, first of all, this is not proved. I mean, there is no derivation for this, right? This is more like, okay, somebody came up with the idea, and when you try to find it experimentally, you actually find the results close to that. But let me tell you, there is no proof, and there is nothing like this is not even intuitive, right? Because इसके आने से इसको क्यों नहीं फर्क पड़ेगा, दो लोग बातें कर रहे हैं, it's a very vague kind of analogy, but two people are talking to each other, a third person has to be interfering somehow, right? How can you just ignore the presence of the third thing? But then experimentally it looks like. Also we did it in coulombs forces, right? This is 5 coulombs here, and we'll do the same thing with waves now. That's what I'm trying to explain you. 4 coulombs, 5 coulombs at a distance of 3 meters. Okay, this will experience a force of k times 5 times 4 divided by 3 square. Now let's say I put another coulomb here, maybe 6 coulombs at a distance of 4 meters, and negative 6, इसको negative कर दो, ठीक है? So then it will have an attractive force here, k times 5 times 6 divided by 4 square. Now, principle of superposition says you calculate the black one independent of blue, then calculate blue independent of black, and then find the resultant there. Okay. Now, same thing applies with waves. So let's say there is a string here. Let's say there is a string. Okay. अब string में क्या है? You make a wave travel. Wave ऐसे travel कर रही है. अब pulse बना दो, wave रहने दो, pulse बना दो. There is a pulse that is traveling here. Okay. And then there is another pulse that is traveling here. Okay. Now let's say this pulse is 1 centimeter and this pulse is 2 centimeters. अब क्या होगा जब यहाँ पे meet करेंगी, when they meet here, what happens to this point? So again, principle of superposition, you say, okay, because of the black one, this point will go 1 centimeters up, but then I'm ignoring green at this point, right? And then when I talk of green, because of green, it will go 2 centimeters up, I'm ignoring black. But then you say, okay, I'm going to add them up vectorially. Vectorially here is going to be pure addition because they're in the same line. So what will happen here is it is going to go by 3 centimeters here. ठीक है, उसके बाद क्या होगा? Let's draw the phases here. So when they meet, you actually see a 3 centimeters of rise there. ठीक है, and then उसके बाद क्या होगा कि they will move on as if nothing happened. So this will go with 2 centimeters here in this direction, 2 centimeters, as if they never met. This will keep going, and this is 1 centimeter with the same speed and in the same direction, that nothing happens. Now if one of them was ulta, then you subtract it. It's all vector addition, right? So this is more like interfering. Two waves are interfering here. This is constructive interference that we saw. It can be a destructive interference. So this is this, and this was this, right? So then this is 3 centimeters, let's say, and this is 1 centimeter, let's say. When they meet, so it's going to be 3 minus 1 in the negative direction. So it will go 2 centimeters here. This is a destructive interference. They're destroying each other. And these are constructing each other. So this is called constructive interference. Any doubts, any questions, any puzzles, anything that's not clear here? Any confusions? Ninad, any confusion? Aviraj, anybody? I mean, I will take all the names one more time to boost your enthusiasm maybe. Abhiraj, Atri, Grishma, Abhinaya, M. Ashik, Manjushri, Mrunal, Ninad, Rhythm, Rukaya, Sai Kumar, Shivangi, Shreya Bhatt, Shreya Hegde, Trisha, and Vasudeva. ठीक है, कोई डाउट नहीं है किसी को? ठीक है. So briefly I'll explain you what is interference now. Okay. And then we have to do interference of electrons also. That was not covered earlier, but after we do this, we'll do interference of electrons also. Right now we're doing interference of light, right? Light is a wave, it interferes, but then electrons are also wave, they interfere. You and I are also waves, we both interfere, right? So let's see what is Young's double slit experiment in brief here. So let's say there is this, and I'm making big here, like these are really big slits, but in reality they are like micro and nanometers big. There are two slits here. ठीक है, two slits. अब इसमें क्या होगा? Look at what we did earlier, and I'm going to wipe this out. There's a wave front here. There's another wave front here. There's another wave front here. Now, because of uncertainty principle, remember, bending of light. This is one way to look at it. Another way to look at it is, or maybe another way I can superimpose here. So this, but in reality, what's happening here is the rays of light are traveling straight. These are parallel rays of light, but they will bend here. Does everybody understand what happened just now? Yes or no? Clear, yes or no? Okay, Vasudeva is clear, right? Now, others, I'm assuming if you're not saying, then you're clear. Another way to look at it is it doesn't have to be parallel rays of light. Maybe this ray of light, these was wave fronts here, right? But then what happens is this becomes a secondary source of wavefront, and this becomes its own secondary source of wavefront. So waves come here, they split, they break into two parts, and each of them is a complete wave in itself. Right? Think about water waves. There are two gates there. Both the gates will create the same kind of pattern there. ठीक है, so far clear, then I'll proceed. If so far clear. Yes, Vasudeva, you're right. Right? So each of them has become a source, right? So now let's draw what happened after this. So let's ignore whatever was before. So there is one wave here, and then there is a trough here. Right? Everybody understands crest and trough, right? So crest is the highest point, trough is the minimum point. So I'm trying crest and trough there because we will be using this information. That's why I'm doing this. So then another trough, another crest, right? So and so forth. Now these colors are for illustration. These are not the colors of the light. So the यहाँ से red बना दिया. Maybe we'll draw blue there, right? So एक crest आ गई, trough आ गई. Right, same kind of distance बनाना चाह रहा हूँ मैं so that they're same wavelength there. So ठीक है, this is good. And then crest आ गई, and then trough आ गई, and then crest आ गई, right? And so forth. Yes or no? This is clear. Yes or no, please. Please tell me, is this clear so far? ठीक, everybody has to write because I'm assuming some students don't speak but they don't understand maybe. So or you're hesitant. Maybe you understand it but you're hesitant in saying yes also. Quickly tell me. ठीक है. So now let's look at this. What happens here? Now before I do that, let me revise what I said. So let's say this was a crest and this was a crest. When they meet, it's going to be a constructive interference. When a trough kind of thing meets with a trough kind of thing, this is also constructive interference because they are going to construct, they are going to add. But then when a crest and a trough meet, that's more like destruction. So this is constructive, this is constructive, this is destructive, and it can be partial also. That's what we'll do when we do mathematics of that, right? So right now we are just trying to understand qualitatively, not quantitatively. Now let's look here what happened just now. At this point, trough and trough met. Oh no, crest and trough met. So this is going to be a destructive interference here, isn't it? The solid line meeting with the bore line or the broken line. This is going to be a constructive interference. This is going to be a constructive interference. This is going to be a destructive interference. Right? Does everybody understand what I'm trying to say? Dots and dots mean that is constructive. Solid mean that is constructive. Solid and dots mean that is destructive. ठीक है. अब इससे क्या होगा when you make a wall here, let's say this is a screen पर क्या होगा कि you will actually see destructive here, also constructive here, sorry. You will see constructive here, you'll see destructive here, you'll see constructive here. So the pattern you will see is really bright spot. So you'll have bright here, then you will have dark here, then you'll have bright here. Because dark, क्यों? One light destroys another light. So that is dark. Dark here, bright here, dark here, bright here, dark here, bright here, and so forth. You'll see this pattern actually. And this is actually where we start thinking of waves, because before this, the notion was that light is particles. So now when you think of light as particles, let's try to understand what Jungs experiment started with. So Young's double slit experiment, until that time, the light was thought of as particles. Now, when you think of particles, think about there are two holes in the wall there, and you start taking ball and you start hitting. Particles are balls, right? You hit them. Now, what would you expect actually? And there are nice videos on YouTube also if you want. Now, you would actually expect that balls are coming from all over the place. You have a machine that throws the balls, right? So what you are going to expect, like common sense wise, you're going to actually expect this. Let me draw. You're going to expect a lot of balls collect here in front of this window. Lot of balls collect here in front of this window. Yeah, everybody agrees this is what you should expect. And virtually zero balls here. बीच में तो कुछ है ही नहीं यार, वहां कैसे आ जाएगी बॉल? एक आध कोई बाउंस होके maybe will come here, one of them bounces here. This is what you expect from particles. They accumulate in front of the window here, in front of the window here. That is expectation. Reality is this. Reality is this. I'll draw with the red color. This is what you expect. And then maybe I'll draw another screen here and show you. Reality is this. Lots of balls here at the center, lots of them. ठीक है, maybe no ball in front of this window and then lots of the balls here. ये हो क्या रहा है यार? This is more like not intuitive. ऐसे कैसे हो सकता है यार? This is what you actually experimentally see. This is what is happening now. You're thinking that balls will accumulate in front of this and in front of this. You really find that the ball actually accumulate here, and where you were expecting zero, क्योंकि इसके आगे तो आ ही नहीं सकता ना, कैसे आ जाएगा? Balls are going straight. So you actually see the bright spot there, lot of light there. और यहाँ जहाँ तुम सोच रहे थे बहुत सारी balls आएंगी, वहां हो सकता है destructive हो गया यहाँ पे. The waves killed each other. And this is where you start thinking of, no, light is not particle, it is wave. Anybody who did not understand, please tell me. We are going to start with mathematics in the next class. We are going to calculate kahan par destructive hai, where is it in destructive, where is it constructive, and all that in the next session. So yes or no, poll coming up. Have you understood so far? Yes or no? True means understood, false means not understood. Yes, Abhinay, I'll do that once again. So Abhinaya, which part is not clear to you? And other students who are saying not clear, tell me which part. कि पूरा नहीं समझ में आया कि part of it is not clear. Which part, Abhinaya? And anybody else, please. Which part? Red part, black part, not all the parts. Please tell me, Abhinaya, fast. Type fast. Hello. The red part. Okay. So what we are saying is, think about the balls coming here, like straight. Do you understand, everybody? You are going to expect that the balls are going to be accumulated in front of this window number 1 and window number 2. है ना ये expectation है, like some balls will go through this. So I randomly throw balls. There are 2 windows here. Behind there is a screen. Maybe balls are dipped in paint. So paint उस wall में इकट्ठा हो जाएगा, ठीक है, in front of these 2 walls. This is what we expect. In reality, what we observe when we do this experiment, we see lot of light here in front of this is a barrier here, right? So how can the ball come this way? It's more like this is happening. I mean that's impossible. I mean, first of all, that's not even going to make sense. And then there is nothing here. ऐसा कैसे हो सकता है? Balls were going here. Why is there 0 ball there? Right? So in reality, what happens is what you were expecting here was a bright spot here, bright spot here. These were laser lights, let's say, and dark everywhere else. In experiment, you find bright here, dark here, bright here, dark here, bright here, dark here, dark here, right? Alternating bright, dark, bright, dark. But that's more like waves because waves interfere. Just हमने देखा, waves interfere. So that shows light is not particles, light is actually wave because particles don't have interference pattern. Waves have interference pattern. Okay. As if this was not confusing enough, somebody tries to do this experiment with electrons. Light is a wave, chalo ho gayi baat khatam. But electrons are particles, right? So instead of having a light now, you do the same Young's double slit experiment with a gun of electrons, like a source of electrons I shoot kare or electrons, 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 right? So now obviously what you're going to expect is, okay, electrons are at least particles, right? So electrons यहाँ से आ रहे हैं, electrons यहाँ आ रहे हैं, electrons यहाँ आ रहे हैं. These are all just electrons. This is not even light. Now you're going to expect this thing at least with the electrons. No, these are electrons. These are not waves. These are particles. This is what you're expecting. But what is the result now with electrons? I'm saying with electrons, not even light. With electrons, you see the same thing. With electrons, shows electrons are also waves. Does that make sense now? Right? This is dual nature of radiations. You have to study both. Both of them are in your syllabus. So this proves that light is a wave. This proves electrons are also waves. ठीक है. Now this is really strange क्योंकि ऐसा नहीं है कि like electron ये वाला आया and this electron comes here and constructively superimposes with this one. No, not this thing. It is more like this. If you really go behind the scenes, it's more weird than you're thinking. It's more like this. मैं electrons एक के बाद एक भेज रहा हूँ. It's not like one electron from here interferes with this electron here. No, I will wait here. What I'm trying to do here is there is an electron here and this electron had a choice, should I go here or should I go here? Please listen carefully. This is really different. Abhinaya, please listen here. Electron had a choice to make. Electron had a choice to make, should I go here or should I go here? What does wave do when it has a choice? What did the wave do? Wave did not choose one thing, it chose both of them. Right? Wave did not say I will go here or I'll go here. Wave said I'll go both the places. So now what is happening behind the scenes is this is one electron. It had a choice to make. This one electron goes through here also and goes through here also. Now anything more than this is going to be quantum physics. I'm not going into that. So this one electron is actually going both the places, not two electrons. This is one electron. Because it had an option to go here and it had an option to go here, it will go both the ways. And this is going to interfere with itself now. So one electron, because it is a wave, it's one electron going both of the places and constructively interfering here, destructively here, constructive here, destructive here, because it is a wave. Any confusions? Not more details, but up to here, because anything more is going to be quantum physics. I'm not going there. Okay, if there are two choices, probability 50-50, then this is going to be both of them. Probability 60-40, yeah, more of it there, probabilistic, less of it here, probabilistic. This is one electron, not two or three, just one. Okay. So this is how we are going to prove that wave nature of electrons and wave nature of light. Now in Wednesday class, we are going to do this mathematics now. Or maybe I should leave now because this is too much. So doubts now, please. 5 minutes of doubts. Yeah, anybody has any questions, any doubts? Questions, doubts, please. Anybody, please come up. Nahi hai questions. In the meantime, I'll fill this form here. Yatri has left. That's fine. That's fine. You can leave if you want to. So, kahan gaya? Wave optics kahan gaya? Ye raha. So, wave fronts and interference. Let's say we are still working on this. No assignments for now. Started wave optics. Introduced wave fronts. Did little interference. Will do mathematical part of interference. Okay, no questions means we'll leave then. Yeah, you can leave. Just see the good night message if you want to, please. I really work hard to get those messages. Yeah, there is a question here. Hold on, please. ठीक है, ये तो खत्म हो गया. ठीक है. Vasudeva says, sir, how electron gets excited? If it is integral multiple of Planck's constant, it should not be in between. No, sir. Yeah, Vasudeva, your question is really awesome. Vasudeva has asked very good question. I think I have already covered that earlier. But this is more like Vasudeva is asking me this. And that's really awesome question. Because see, electrons are, the shells are quantized, right? So electron can either be here or it can be here. It cannot be anywhere in between. Even for a microsecond, nanosecond, it cannot be here, because even if it is 10 to the power minus 100 second there, you're violating all these equations, right? So that's not going to work. Right. So now let's, because Bohr says it can be either here or here. But if you're saying 10 to the power minus 100 second also it is here, then you're violating Bohr's postulates, and that is not true. That doesn't work. Right? It's more like, this is the example I gave earlier. This is Vasudeva's house and this is Vasudeva's school. I don't have his room there. Yeah. So this is school. Now we are saying Vasudeva can either be at school or at home. Right? He cannot go to anywhere else but school or home. But then at some point of time, maybe even if it is very close and Vasudeva has to walk, run, bike, take a helicopter, jet plane, something. So Vasu has to be somewhere here, maybe shorter duration, but not zero duration. But we are saying, no, you're not allowed here. It's more like you are here and you disappear here and you reappear here. You cannot be somewhere in between. And that's exactly what happens. And the way it happens, I cannot explain until and unless I go into the quantum world. And also this is more like, see, the point here is this is still wrong anyways, right? When you're saying electron is here, you're saying, oh, I know with 100% certainty it is here, but that violates uncertainty principle. So there is a probabilistic cloud that the electron is here, this one electron. So let's go to another page. So this is one electron. This is not a lot of electrons. Electron has a probabilistic cloud over there, and that goes with the probability here also. So everything is quantized. You cannot be in between spaces there. Energy is quantized, momentum is quantized, mass is quantized, everything is quantized. And the way it works is you really have to understand the quantum theory now in detail. Take a verse, so I cannot explain anything further than that. It's not that I don't know, but I will not be able to explain it in simple words there because there is no simple answer. Clear? Question was great, yeah. So you're saying, okay, electron was here, oh, it disappears here and comes here. You can visualize that way, but the electron was never there, right? It's probabilistic here and here. There's a probability cloud of electron being here or here. One of the probability wins. So when you observe, things are different than when you don't observe. And this is why Einstein hated quantum theory. He was the pioneer. He started all this. But as soon as you say, um, one second. So his famous statement, God does not play dice. So you're saying probability means what you're saying is God is playing dice. It's trying probability, right? It's more like a game of chance. So his statement was, God does not play dice. The moon is there whether or not I watch it. Because in quantum world, you say when you're observing something, things are different. When you're not observing everything, probabilistic wave is there. And when you observe it, the wave breaks and it chooses one of them. That's what happens. So then when you said, okay, electron comes here, the same electron was going here and was going here. Now you say, I'm going to observe what happens. ऐसे कैसे हो सकता है यार? But as soon as you start doing that, this happens. Literally this happens when you observe it. Because now electron says, I'm not going to reveal that, I'm going to go through this. Another electron comes and it goes through this. And you actually see the particle nature now. So when you don't observe it, you see the wave nature. When you observe it, you see all this, what you were expecting. This is when you're observing it. Clear? So this is really very strange world. You don't go into that for now. Okay? So good night message दिखा देता हूँ. It was somewhere around page number 60 if I'm not wrong. Because I uploaded more slides now after that. Yeah, somewhere here. हाँ ये देखो भाई क्या लिखा है. Never let I think this I already covered earlier. So this is an old message. Sorry for that. Okay. So good night everybody. Please study interference pattern. Do the mathematics part as in where you see bright and dark spots and then come prepared. Good night everybody. Bye bye.